There is a world beneath the surface, vast, cold, dark, and largely unexplored. A world where sound resonates beyond light's reach, where some of the largest creatures to ever exist move in near silence. The waters surrounding Iceland are truly a remarkable place. Cold Arctic currents crash into warmer Atlantic flows. This creates a nutrient-rich environment that hosts a diverse assortment of wildlife, becoming a particularly special haven for whales. Join me as we delve deeper into the various whales that frequent Iceland's shores, showcasing the magnificent depths they go to in search of food, the amazing annual migration patterns, and even get a glimpse into the trials of being a newborn calf in this vast ocean. A whale's migration across the globe reflects the health and balance of the ocean. Many species travel thousands of kilometers each year to reach these feeding grounds, navigating vast emptiness along routes shaped by ocean currents, temperature gradients, and the promise of food. In Icelandic waters, fish, krill, and plankton are plentiful. A humpback may consume as much as 1,800 kilograms per day during peak feeding season. They build reserves of blubber for the long journey to the breeding grounds where feeding stops almost entirely. These environmental factors guide whales along predictable pathways, though the exact mechanisms of their navigation remain one of science's great mysteries. Humpback whales are among the most notable visitors to Iceland's waters. These magnificent baleen whales typically reach lengths of 12 to 16 meters, easily identified by their exceptionally long pectoral fins, sometimes up to 1/3 of their total body length. Their heads are covered in small, rounded bumps called tubercles, and their tail fluke displays a unique pattern of black, white, and sometimes brown, no two alike. They spend their summer and early autumn feeding intensively in these cold, nutrient-rich regions. Then, as October fades into November, many begin their migration south. They leave Iceland's rich feeding grounds behind, traveling thousands of kilometers towards tropical breeding areas near Mexico and the Caribbeans. By late spring, they begin their journey northward once again, returning to refuel and repeat this ancient cycle. Minke whales, by contrast, are among the most consistent residents of Iceland's waters. Significantly smaller than humpbacks, they usually measure between 7 and 10 meters in length, with sleek, streamlined bodies built for speed. Unlike humpbacks, minke whales are less dependent on long-distance migrations. Adaptation has allowed them to remain in colder regions longer, continuing to feed even as the seasons shift. Depending on timing and location, Iceland's waters may also reveal fin, orca, or pilot whales. But of course, we can't forget the almighty blue whale, the largest animal to ever exist. Twice as large as any dinosaur who's ever walked the earth, and their heart can be as large as a small piano. They attain this great size thanks to the buoyancy inherent in water, allowing them to grow beyond normal limitations set by our gravity. And about 5 million years ago, as the Ice Age came to a close, an increase in phytoplankton led to an overabundance of krill. This is a blue whale's favorite meal. Their lunge feeding method was perfect to take advantage of this bountiful surplus. Despite spending nearly their entire lives beneath the surface, they remain fundamentally tied to the air above. This dependence creates a visible, rhythmic pattern, the breathing cycle. At sea, this rhythm becomes one of the first signs of their presence. A sudden burst of mist, a brief rise to the surface, then disappearance. Whales are often seen surfacing multiple times in succession, taking several breaths in short intervals before committing to a deeper dive. One of the most defining moments in this process is the lifting of the tail fluke. When a whale arches its back and raises its tail above the water, it signals a transition from the visible world to the world unseen. This movement typically indicates longer, deeper dives where the animal disappears entirely beyond the reach of light. Dive times can vary depending on species and activity. Minke whales typically dive for 5 to 20 minutes, their dives shorter and more frequent. Humpback whales are capable of diving longer, generally 10 to 30 minutes, often associated with deeper feeding. Marine research suggests these differences are closely linked to body size, oxygen capacity, and feeding strategy. Yet, even with these known ranges, each dive remains unpredictable. From the surface, there is no way of knowing where a whale will reappear or how long it will remain below. Newborn whales exist in a completely different reality. At birth, they are not equipped for deep diving. Instead, calves remain close to the surface, relying on frequent breaths and constant proximity to their mothers. Their early life is defined by limitation, but also by rapid, remarkable development. During the earliest stages of life, the calf feeds exclusively on its mother's milk, one of the richest natural substances in the animal kingdom, with fat content reaching up to 50% and 30% being rich protein. Calves can gain an average of 90 kilograms per day during their first few months, building the strength and insulation required for colder waters. As they grow, a series of physiological adaptations begin to take shape. Increased oxygen within the muscles and blood, enhanced lung capacity, improved tolerance to the pressures during descent. These changes are critical. Over time, they transform the calf from a surface-dependent newborn into a deep-diving marine mammal capable of surviving in extreme underwater conditions. At the same time, learning is taking place, not through instruction, but through observation and repetition. As the pair eventually migrates northward, the calf is exposed to the full scale of the ocean. This journey becomes critical for its learning. The mother, in this sense, is not only a source of nourishment, but a guide through an unforgiving world. Beyond their size and presence, whales play an essential role in maintaining the balance of the ocean's ecosystem. Their importance extends far beyond what is immediately visible, influencing processes that sustain life both in the ocean and on land. One of the most significant contributions whales make is through the nutrition recycling process. As they move through vast areas of the ocean, they help redistribute nutrients vertically and horizontally. When they feed at depth and return to the surface to breathe, they release nutrient-rich waste into the upper layers of the ocean. This process supports the growth of phytoplankton, microscopic organisms that form the foundation of the marine food chain. These plankton are not only essential for marine life, but also produce a substantial portion of the world's oxygen. Whales also contribute to the regulation of Earth's climate in ways only recently understood. When a whale passes away and its body sinks to the bottom of the ocean, it effectively locks away large amounts of carbon, removing it from the atmosphere and storing it deep within the ocean for extended periods. This process is known as carbon sequestration. It positions whales as natural regulators within the global climate system. Despite the decades of scientific research, whales remain among the least understood large animals on Earth. Much of their lives unfold beneath the surface, beyond the reach of direct human observation. As a result, many aspects of their behavior, communication, and intelligence continue to raise questions. Whales produce a wide range of vocalizations, songs, clicks, and pulses, which can travel vast distances underwater. Humpback whales in particular are known for their complex songs, structured sequence of sounds that can last for hours and evolve over time. These vocal patterns are often repeated and shared among populations, suggesting a form of cultural transmission. Yet, despite extensive study, the exact meaning and purpose of these sounds remain largely unknown. Whether they function as language, navigation tools, or social signals is still being explored. Research indicates they possess complex social structures, long-term memory, and the ability to solve challenging problems. Some species display cooperative behaviors, working together while hunting and as they migrate. These observations suggest a level of intelligence that challenges previous assumptions. However, the true extent of their cognitive abilities are not yet fully understood. There are fundamental questions that remain unanswered. How do whales navigate across entire oceans with such precision? How do they communicate across vast distances in the deep sea? What behavior occurs in the depths beyond human technology's reach? The reality is, much of this is still unexplored. What is visible to us represents only a small fraction of their lives, a world that remains in many ways hidden. Understanding whales is not just a matter of curiosity, it's discovering the fabric of nature, intricately woven together, all to protect the balance of life. We must continue the unending endeavor of learning and the protection of our partners in this beautiful world.